These are the solutions to question number 3 from the 2017 Linear Algebra examination. So part A is concerned with subspaces. Part B, we want to find the coordinates of a vector with respect to a basis. And question C, we want to show that these three vectors are linearly independent. So for part A, we look at W1. And the first thing you should do is show that these subsets are non-empty. Now W1 is non-empty as 1, 1, 1, 3 belongs to W1, because as you can see here, A plus B plus C does equal D. Now we take two general vectors which are in W1. So we take A, B, C, and notice that D is A plus B plus C. And here's another vector, D, E, F, and you'll notice that this element in the matrix is equal to D plus E plus F. So both U and V belong to W1, and we take alpha is a real number. Then alpha U plus V is alpha times this matrix plus this matrix. We multiply all of these out, and you'll see that these three added together do give this element. So therefore this vector, which is alpha U plus V, is also in W1. So therefore W1 is a non-empty subspace of M2R. Now for W2, we're going to show that this is not a subspace. So first of all, we show W2 is non-empty because the vector 1, 1, 2, 2 does belong to W2, because A plus B plus C is 1 plus 1 plus 2, which gives you 4, which is the same as 2 to the power 2. So this vector is in W2. However, 2 times this vector gives us the matrix 2, 2, 4, 4, and this one is not in W2 because 2 plus 4, which is 8, is not the same as 2 to the power 4. So therefore W2 is not a subspace. Now for part B, we want to find the coordinates of this vector with respect to these basis vectors. So we want to express this matrix as these three added together, and we need to find A, B, and C. So if we equate the elements in the matrix, so in row 1, column 1, we'll have minus 1 is A plus 2B plus no C's. And then we do the same for the other elements in the matrix. And we get these three simultaneous equations, because in the final one we get 0 is 0. So we have these three simultaneous equations. You solve these and we get A is minus 7 over 3, B is 2 over 3, and C is minus 1. And this is how we write down the coordinates. Remember, we use square brackets to represent coordinates. And then for the final part C, we want to show that these three vectors are linearly independent. So we need to prove that A, B, and C are all 0. So again, we look at the elements in the matrix. We get these three simultaneous equations, and you can show that the only solution is A equals B equals C equals 0. Therefore, these vectors are linearly independent. And that concludes the solutions to question number 3.